The speedometer needle has crossed 68 miles per hour, and it is still climbing. The service brakes are useless, glazed, overheated, gone. Below the Eisenhower Pass on eastbound Interstate 70, a 105,500-pound Kenworth has become a projectile. Just 34,000 pounds of frozen freight rides behind the cab, pressing the combination forward with pure Newtonian force. The 7% grade gives gravity exactly what it needs. The driver knows the ramp is out there, somewhere ahead. He has a few seconds to commit to the right angle. One miscalculation and that ramp becomes a catastrophe. This is the story of how a January morning in Colorado exposed a fatal flaw hiding inside standard operating procedure. January 2003. A refrigerated freight run has been dispatched along I-70 toward the Colorado Front Range. Yet the route crosses the Continental Divide through the Eisenhower-Johnson Memorial Tunnel, one of the highest vehicular tunnels on the continent. The truck assigned to the haul is a Kenworth W900L, 130 inches of hood stretching forward from the firewall to the bumper. As introduced in 1990 as Kenworth's long hood flagship, the W900L was engineered for maximum gross weight long-distance work. Beneath that long hood sits a Cummins ISX, displacing nearly 15 liters across 6 inline cylinders. And rated at 600 horsepower and 1,850 pound-feet of torque, it ranks among the most capable production diesel engines in North American trucking. The trailer is a 43-foot refrigerated unit carrying 44,000 pounds of frozen food product. Combined with the tractor weight, and the gross combination weight reaches 105,500 pounds, a figure that demands respect on any sustained mountain grade. The trailer runs a single-circuit air brake system, functional for the configuration but with narrower safety margins than dual-circuit designs. At the pre-trip inspection, no faults were logged. The truck cleared the terminal before dawn. One critical decision was made during that morning's preparation. The Cummins engine brake, the Jake brake, was left disengaged. The reason was never documented. Its investigators would later identify it as the primary procedural failure of the entire event. The truck entered the eastbound approach to the Eisenhower-Johnson Memorial Tunnel at 11,013 feet above sea level. On the eastern slope, as the grade steepens to 7% and holds that pitch for more than 5 continuous miles, the driver engaged the service brakes at the crest of the grade, standard operating practice. For the first 2 miles, the combination held controlled speed. By mile 3, and the brake drums were absorbing more heat than they could shed. 4 miles of continuous pedal pressure had cooked the brake linings. At mile marker 218, the thermal threshold crossed into irreversibility. The service brakes were still responding, but they were no longer decelerating anything. A fade had become total. If you want to see how this driver guides a runaway Kenworth to safety on that ramp, here's what I ask. See that subscribe button? It's our exchange. Your way of saying this reached you. Hit subscribe if this resonated, and drop a like if it moved you, and tell us in the comments what you know about mountain brake fade and I-70. It helps us share more stories like this. Back to the W900L. The driver already knew the pedal had gone soft 2 miles back, while the combination had been gaining speed with each passing guardrail post. He needed to thread a decision, and he needed to do it before the next curve. At 68 miles per hour, a loaded combination at 105,500 pounds on a 7% grade carries enormous kinetic energy. And that number compounds with each passing second. Nothing about the physics of this situation was theoretical. The Downieville emergency escape ramp appeared ahead on the right. The driver had no alternative worth naming. A flat highway exit ramp at that speed ends in compressed steel, as the ramp was the only viable exit from that equation. The driver steered right. A controlled input, not a panic reaction. The W900L's front axle hit the loose aggregate at high speed, and the loose stone did exactly what it was engineered to do. It grabbed the truck and held on. The front axle buried within 2 truck lengths. The trailer continued pushing forward for another moment, then stopped. No rollover, no jackknife. Just the W900L was disabled in the ramp, structurally intact, its driver unharmed. Colorado State Patrol arrived on scene within minutes. Their post-incident documentation was precise. Brake drum temperatures on all drive axle positions measured above 900 degrees Fahrenheit, yet the drums were still radiating heat into the January air. Investigators pulled the brake linings from every drive axle position. The friction material was glazed, hardened and polished by sustained thermal loading until it could no longer grip a rotating drum. And physics had simply completed its work. Brake fade on a loaded Class 8 truck is not a sudden event. It builds across miles of applied pedal pressure, with each application cycle depleting more of the drum's remaining thermal tolerance. The decline is gradual, then total, and the glazing process is self-reinforcing. As lining temperatures climb past 700 degrees Fahrenheit, the resin binders in the friction compound begin to vaporize. That vapor layer between lining and drum eliminates mechanical contact, and with it, braking force. And by the time the driver felt the first soft pedal response on this January descent, the process was already past its reversal point. The brakes would only recover after full cooling, and the mountain grade would not wait. The engineering analysis confirmed one overarching fact. Disengaging the Jake brake at departure had removed the only sustainable retarding force available on that grade. The service brakes were never designed to carry that load alone for 5 miles. And a Cummins ISX, equipped with the Interstate compression release system, generates up to 600 braking horsepower. At maximum gross weight on a 7% grade, that retarding capacity is the measured difference between controlled descent and runaway. Yes, the driver had operated heavy freight through mountain corridors before, but that morning's combination, maximum gross weight, thermally compromised linings, and no engine retardation, had narrowed his operational margin to essentially nothing before mile marker 218. As the State Patrol's report flagged the pre-trip inspection protocol, post-incident lining analysis identified the glazing as a pre-existing condition, thermal damage accumulating across multiple prior descents. The brakes had been failing slowly, invisibly, for some time. And this is the quiet failure mode that mountain freight corridors expose. A brake drum can cool overnight in a terminal yard and show no exterior signs of degraded lining compound. Visual inspection cannot see what heat has already done inside. And post-incident analysis submitted to the FMCSA noted the single-circuit trailer brake configuration as a contributing factor. Dual-circuit systems provide redundant retarding capacity. A design margin this trailer's brake architecture did not include. And the incident triggered a formal review of pre-trip brake inspection standards for commercial vehicles on the I-70 mountain corridor. Colorado's sustained grades had been creating margin problems for years. This incident placed them in documented record. The Eisenhower Johnson Memorial Tunnel sits at 11,013 feet above sea level. The eastbound descent to the Denver Metro drops roughly 3,500 feet across 50 miles. The grade averages 4%, but concentrates to 7% in specific sections, and eastbound trucks leaving the tunnel face. That 7% pitch immediately. Applying service brakes to hold speed is the natural instinct, and also the fastest route to thermal overload on a loaded combination in sustained descent. Engine brakes exist precisely for this terrain. Thus, the Cummins interbrake compression release mechanism uses the engine's cylinders as air compressors, creating retarding torque without heating wheel and brake components at all. The Jake brake is a mountain descent's first line of defense. At the time of the 2003 incident, a regulatory guidance on engine brake use in mountain corridors existed, but enforcement was inconsistent. Some drivers disabled them to reduce noise near towns or to comply with posted ordinances. The gap between rule and practice was real, and the Kenworth W900L was extracted from the Downieville ramp, inspected thoroughly, and returned to service after a complete brake system replacement. The reefer trailer's frozen cargo was assessed on site. The driver was cleared after the investigation concluded, and the W900L's 130-inch hood had absorbed the ramp entry without structural compromise. That long-nose design, sometimes questioned for aerodynamic efficiency, demonstrated its structural character. The front axle took the impact, and the cab stayed intact. The Downieville Emergency Escape Ramp, located near exit 234 on eastbound Y-70, is filled with clear stone aggregate sized to generate rolling resistance without launching a trailer upward. Every cubic yard of that material has a specific engineering purpose. Ramp engineers calculate the aggregate depth and incline angle to decelerate a fully loaded combination from over 80 miles per hour to a full stop within 300 feet. Every dimension of that bed is the product of deliberate calculation. Following the 2003 incident, its CDOT and Colorado State Patrol accelerated their collaboration with the Colorado Motor Carriers Association on mountain corridor safety. The focus shifted deliberately from post-failure response toward pre-departure brake verification. New brake temperature monitoring technologies began entering fleet safety programs across the Western freight network. Thermal inspection strips and infrared drum sensors, tools available but underdeployed in 2003, received renewed attention from fleet safety officers nationwide. Yet the I-70 corridor has since developed one of the most comprehensive mountain trucking safety programs in North America. The Mountain Rules Initiative delivers in-cab audio alerts, grade warnings, and real-time brake check location data directly to commercial drivers. The Lower Straight Creek Runaway ramp on westbound I-70 at milepost 211.83, just west of the Eisenhower Tunnel, remains the most heavily used emergency escape ramp in the United States, recording multiple truck entries in most calendar years. As that ramp has stopped trucks traveling well above 80 miles per hour. Its aggregate field is maintained seasonally, its approach markings extended uphill to maximize driver decision time, and its stone composition periodically renewed after each extraction event. As extracting a disabled combination from an escape ramp is its own technical discipline. Specialized towing teams rig front axle recovery cables designed to pull the truck backward without bending the frame rails or destroying what the ramp just saved. The January 2003 incident was not isolated in its physics. What distinguished it was the documentation quality. Drum temperatures, lining condition, Jake brake status, and payload all logged with precision, creating a reference case for the investigations that followed. And the Kenworth W900L carried no structural fault in this event. The truck performed precisely as designed. Its mass transferred into the ramp aggregate exactly as ramp engineers had calculated it would. The machine did not fail. The procedure did. The fault was operational, as not mechanical. A single disengagement decision, made in a terminal yard before dawn, before a mountain run, removed the one retarding system that could have managed every mile of that 7% grade. But this is what makes the January 2003 Eisenhower Pass incident a precise case study. The truck was correct, the grade was marked, the ramp was in position. The only variable was a procedural decision made before the descent began. As the Kenworth W900L remains in production today, still hauling freight through mountain corridors across the American West. Its long hood and twin stacks are as identifiable on a Colorado grade in winter as they were on that frozen January morning in 2003. Heads of the W900L. L sits quiet now, rebuilt, recertified, back on the road it was built for. The mountain is still there, still 7%, still waiting. If this story moved you, please like and subscribe. As your support helps us preserve these machines and the histories behind them. Tell us in the comments where you're watching from.